Welcome back, folks. So now we want to go ahead and look at the exponential function e to the x and its inverse, the natural log of x. So let's take a look at that. Okay. So here we've got f of x and g of x. F of x is the exponential function e to the x. Just as a reminder, this is e is approximately the number 2.718. It's a transcendental number. It never repeats itself. And a lot of times students struggle with the exponential function because we write the letter e here. But if you like, just keep in mind that this is a number between 2 and 3, and you just saw how to graph 2 to the x, and graphing 3 to the x would be similar. Okay. Likewise, we write this as the natural log of x, and we saw this in that previous pre-work. But if you were to, in your head, think of this as log base e of x, there's nothing wrong with doing that. Okay, so let's go ahead and sketch the graph of e to the x. I'm going to sketch that in this magenta color here. We just said that any exponential function prior to transformations has to pass through the order pair 0, 1. Likewise, the number e is about 2.718, and if I were to take e to the first power, so what I'm saying here is if I were to evaluate f of 1, that would give me e to the first power, which is just e. So when I plug in a 1, I get out the number e, which is about 2.71828. So there's the number e. There's the order pair 1, e right there. Okay. And now we said that the graphs of our exponential functions always have horizontal asymptotes at the horizontal line y equals 0, so I'll go ahead and sketch that. That's prior to any transformations. And here's a nice fact that just helps me sketch this graph a little bit better. E to the third power is approximately 20. It's not equal to 20, but it's approximately 20. So I'll just put the order pair e to the third, approximately 20. So I plugged in, I'll plug in the order pair 3, approximately 20, and I'm saying that because e to the third is about 20. So now I can go ahead and sketch the graph of e to the x, and it retains basically the same shape as the 2 to the x graph that we sketched on the previous page. So there's my graph of f of x equals e to the x. So from this graph, we can again identify the domain. But of course, we knew this. The domain of any exponential function is going to be minus infinity to infinity. Likewise, from the graph, we could identify the range, or we just keep in mind that when I plug a number into an exponential equation, it's impossible to get out 0, and it's possible to get out something negative, so the range is 0 to infinity, not including 0. We have the same easy points from before. There's the order pair 0, 1, and there's the order pair 1, e. I guess this requires us to know the decimal approximation of e to put that point on there. And just as before, we said for any exponential function, we've got a horizontal asymptote at y equals 0. So now let's go ahead and do the same thing for our natural log function. And because of the domain range relationship between a function and its inverse, we know that since our function e to the x passes through 0, 1, then the natural log of x has to pass through the order pair 1, 0. Likewise, let's go ahead and put that down as one of our easy points, 1, 0. Another easy point is that we've got to pass through the order pair e, 1. So e here, you can see I made a little tick mark for you. There's the order pair e, 1 right there. And likewise, we know that if we plug in the number 20 into our natural log function, we're going to get out something close to 3. So here we would have the order pair 20, approximately 3. So there's the order pair 20, approximately 3, and that's because the natural log of 20 is a little close to 3, and that just gives me a third point that I can graph on here. And so then now we can go ahead and sketch the graph of our logarithmic function, the natural log of x, and we see that its graph looks something, oof, that's not the best. So there I've sketched the graph of the natural log of x. There's our g of x equals the natural log of x, and we see the same domain range relationship. We see the same symmetry about the line y equals x that we do with the graph of both 2 to the x and log base 2 of x. If you've noticed, folks, it's not like I did any new work in constructing the graph of e to the x and natural log of x that I did when I constructed these first two graphs up here for the 2 to the x and log base 2 of x. And I just want to point that out because I've had students in the past who've learned a little bit about logarithms in previous classes, and they've said to me, Charles, I know about 2 to the x, but I don't understand e to the x. Or I know about log base 2 of x, but I don't understand natural log of x. And I just want to show you that structurally, these graphs are very, very similar to one another. And if you look at the knowledge that we put on these 2 tables here, it's the same sort of knowledge. What's the domain of the natural log function? It's 0 to infinity because of the domain range relationship between it and e to the x. And its range is minus infinity to infinity. And it has a vertical asymptote at x equals 0. So this relationship here is exactly the same relationship that we had for 2 to the x and log base 2 of x. And notice that their graphs, if I hadn't put tick marks on there, these graphs are virtually indistinguishable. And in our last video, we'll go ahead and look at that a little bit more closely. All right, folks, thanks for your patience, and I'll see you next time.